The first chapter of class 10 science is chemical reactions and equations. In this video, I have discussed the complete chapter. The beginning part of the video consists of the theory part of the chapter with good number of examples. Towards the end of the chapter, I have discussed the textbook exercise questions followed by solutions. So this chapter, chemical reactions and equation, consists of 4 parts. The first part is what are chemical reactions, means what is meant by chemical reactions. Second part is how to balance a chemical reaction. Third part is what are the types of chemical reactions. And the last part is what is the output or what happens when a chemical reaction occurs. To begin with, what are chemical reactions? Chemical reactions are processes in which a new substance with completely different property is formed. During a chemical reaction, no new atom is formed, only rearrangement of atoms undergo, because old bonds are broken and new bonds are formed, or vice versa. So the same atoms which were there in the beginning where the process underwent, they only rearrange, form new substances, and because new substance is formed, a completely different property, object or substance is formed at the end. The substances which participate in the process are called reactants, and the substances which are formed are called products. To initiate a chemical reaction, something should be done, like either the substances, means reactants, should be heated, or the reactants has to be exposed to light, or electric current may be passed or must be passed through the reactants so that the chemical reaction is initiated. I have discussed the complete chapter in form of handwritten notes. The notes in form of PDF I will put in the description. You take a hard copy of it, and before any exam, have a quick glimpse through those notes. When you watch the complete video, at any point of time, if you feel that the discussion is going lengthy, just move forward and go until the end where you will have the textbook exercise questions followed by solutions which is being discussed. Hope this video is very useful to you. So this is the first chapter, chemical reactions and equations. As you read this literature, you will realize that they have explained what a chemical reaction is with few activities, and then converting the chemical reaction in form of equations and then symbolizing them and ultimately balancing those symboled form of chemical equations. So I have written the summarized form in form of notes, and I will explain the complete chapter through these notes, and in which I will be turning the pages and showing you that what exactly I'm discussing in this video. So let's begin. So the beginning part of the chapter should be the meaning of chemical reactions. So what are chemical reactions? These are processes in which a new substance or few new substances are formed which have got totally different properties or new properties. The substances that take part in a chemical reaction are called reactants, and the substances which are thus formed are called product. So when a chemical reaction occurs, what happens? So that will be the characteristic features of a chemical reaction. So during a chemical reaction, a gas may be evolved or a precipitate may be formed. Some change of color of the final product may happen. A change in temperature, like the reaction may be exothermic or endothermic maybe, or a change in the state of matter may happen. So this is what we should know about the chemical reaction. Now, what initiates a chemical reaction? So a chemical reaction will happen when the reactants are either heated or placed in light, or electric current is passed through them. So the ways in which a chemical reaction may be initiated. So first bit, by heating. Let's take an example. So by heating means you can take example of any combustion reaction. Simplest of combustion reaction is when coal burns in presence of air. So carbon plus oxygen. So when coal is heated to its ignition temperature. So I have just kept a delta symbol to indicate that it is heated. So when coal is heated to its ignition temperature, then in presence of oxygen, it burns and carbon dioxide is released, and in the process heat is produced. So by heating means heat is given and heat is given out also. So combustion reaction. Chemical reaction is also initiated when reactants are exposed to light. So the best example can be decomposition reaction. So when silver chloride or silver bromide, you must have seen in laboratories, silver chloride and silver bromide are placed in dark bottles. Some medicines are also sometimes kept in dark color bottles because the light may cause chemical reaction of the ingredient inside the bottle. As a result, the ingredients may decompose. So that's also a decomposition is a chemical reaction. So exposure to sunlight can cause a chemical reaction to happen. So example, silver chloride in presence of sunlight decomposes into silver and chlorine. Chlorine is a yellow colored gas. Okay. And chemical reaction is also possible when electric current is made to pass through any liquid solvent. So best example is hydrolysis of water. So from through water, when electric current is made to pass, water decomposes into hydrogen and oxygen gas. Hydrogen being a positive ion. Of course, hydrogen comes in a negative ion also, but in this case, hydrogen gas. So this will be released at cathode and oxygen will be released at anode. So how to initiate a chemical reaction? A chemical reaction is possible only under three conditions. Either the reactant have to be heated or exposed to light or electric current is made to pass through them. So the next topic is balancing of chemical reactions, and after balancing of chemical reactions, we have types of chemical reactions. So I thought I will discuss the types of chemical reactions, and through those examples, I will tell you how to balance the chemical reactions. So how many types of chemical reactions are there? There are 5 of them, but this can be further broken down and we can name good number of chemical reactions, but these are the basic 5. So the types of chemical reaction, there is combination reaction, decomposition reaction, displacement reaction, double displacement reaction, oxidation and reduction reaction. This can also be called as a redox reaction. So these are 5 of them. Just remember, what is combination reaction? Combination reaction is a reaction in which 2 or more simpler substances combine to form a single substance. What is a decomposition reaction? Decomposition reaction is a reaction in which a single substance under certain conditions is broken down into simpler substances. Displacement reaction is a reaction in which an element of a higher reactivity, like an element that stands at higher position in the reactivity series, displaces a lower reactive substance from its salt solution or from its compound. Double displacement reaction is a reaction in which the compounds exchange the ions to form or they rearrange and form different compounds. Oxidation reaction is a reaction in which oxygen is added or hydrogen is removed or electron is lost. Reduction reaction is a reaction in which hydrogen is added, oxygen is lost and electron is gained. Redox reaction is a reaction where you can see one substance being oxidized and another substance being reduced. Also, combination reaction, every combination reaction is an exothermic reaction. And every decomposition reaction is an endothermic reaction. What does that mean? Combination reactions are exothermic in nature. Its meaning is they will give heat when the reaction is accomplished. Decomposition reactions are endothermic in nature because when this reaction occurs, heat energy is absorbed. As a result, a single complex compound is broken down into simpler substances. Okay, so these. Now let's learn in detail about these. Now let's begin with combination reaction. I have already defined combination reaction. So remember that all combination reactions are exothermic in nature. That means that they definitely release the heat energy at the end of the reaction. How to remember the examples of combination reaction? There are 3 of them. One is the journey of calcium oxide until calcium carbonate. Next, all combustion reactions are combination reactions. Third, all corrosion chemical reactions are also, or they also come under combination reactions. So let's begin with this. The first one, calcium oxide. Calcium oxide is otherwise known as quicklime. or just lime. Calcium oxide is generally it comes in solid state. So when this is mixed with water, water is always a liquid form. This forms calcium hydroxide. Calcium hydroxide is a CaOH2, calcium and hydroxyl group, two of them. This is called a slaked lime. Slaked. I'm not saying the slaked, it's a slaked lime. Then a solution of calcium hydroxide means a slaked lime solution. This, when it reacts with carbon dioxide, forms calcium carbonate and water. So let me explain what exactly this happens. This is the story of whitewashing. That means these days we have putties or the kind of Asian paints or Nerlac paints that is kept to the walls. But once upon a time, the walls were being whitewashed. It means a white paint is white kind of painting was done to the walls. So that is called whitewashing. So this is a chemical reaction what undergoes during whitewashing. There, the calcium oxide, that is quicklime or lime, that is mixed with water. When this mixing is done, then itself the reaction is exothermic in nature. Lot of heat and that results in bubble formation happens. And in the process, calcium hydroxide means slaked lime is formed. So a coating of slaked lime goes to the walls which is whitewashed. And in its cooling process, this calcium hydroxide absorbs, like it loses moisture and absorbs carbon dioxide from the atmosphere. And when the walls are dry, the walls shine bright white. And that is the layer of calcium carbonate. Calcium carbonate has the same composition that marble has. And calcium carbonate is white in color, and in that way we say that the walls are whitewashed and water is released, that of course evaporates. So the first example of combination reaction is calcium oxide when it reacts with water or when it is mixed in water forms calcium hydroxide. Calcium hydroxide when it combines with carbon dioxide of the atmosphere forms calcium carbonate and water. I guess this reaction is well balanced, but let me once check it. So one calcium done. Oxygen, there are two of them, and here also there are two oxygen, and hydrogen two atoms, and here also two atoms. The first reaction is well balanced. The second one, single calcium either sides, and oxygen, here two of them, here two of them. So in the reactants there are four oxygen, and in the product side 3 plus 1 4. So oxygen is also well balanced. Hydrogen two atoms in the reactant and two atoms in the product. So this is a well balanced equation. Now we'll go to the second example of a combination reaction. All combustion reactions are combination reaction. What is the meaning of combustion reaction? Combustion is a process in which fuel burns in presence of oxygen. That means any fuel, solid, liquid, gases, when they are heated to their ignition temperature, then in presence of oxygen, they form carbon dioxide, water, and in the process heat is produced. That procedure is called combustion reaction. So what could be the best example of combustion reaction? Burning of coal. So carbon plus oxygen gives carbon dioxide and heat energy. So this is exothermic in nature. Every exothermic reaction is combination reaction, and every combination reaction is exothermic in nature. Also, magnesium ribbon, that when it is burnt, burnt means obviously burnt in presence of air. So magnesium plus oxygen gives magnesium oxide. So this is the first activity that you'll see in the textbook, where the magnesium ribbon is burnt in presence of oxygen, and that burns with a white sparkling flame, and at the end what is formed is a white fine powder of magnesium oxide. So here magnesium appears, that comes in magnesium thin ribbon rolls. So before burning, that has to be scraped with sandpaper, because magnesium is a pure metal. So in presence of air, that gets oxidized. So already the magnesium ribbons are magnesium oxides. So magnesium burns in air, but magnesium oxide doesn't burn. That is why magnesium ribbons have to be first scraped with sandpaper so that the pure magnesium metal is visible, and that when it is heated to its ignition temperature in presence of oxygen, that gives magnesium oxide, which is white powder, and definitely tremendous amount, good amount of heat energy is produced. So this is a white powder and this is called magnesium oxide. Few more. Hydrogen. Hydrogen is a highly combustible gas. It burns with pop sound when its volume is less. Otherwise, it leads to explosion if its volume is more. So hydrogen, when it is heated to its ignition temperature in presence of oxygen, it burns to form water, and heat energy is produced. Also, any fuel. So hydrocarbons are fuel, carbon is a fuel. Hydrocarbon means all fossil fuels, not all fossil fuels, all petroleum products are carbohydrates. All edible things are carbohydrates. Carbon is combustible. Hydrocarbons are petroleum products, and edible things are carbohydrates. So all of them burn. So when hydrocarbon like methane is heated, then it burns in presence of oxygen to form carbon dioxide, water, and heat is produced. Just remember, every combustion reaction's output is carbon dioxide and water. So when we have to give examples of combination reaction, just remember the first example, the best one is quicklime converting to calcium carbonate. Next, all combustion reactions. And the third one is all corrosion chemical reactions are also combination reactions. What is the meaning of corrosion? Corrosion is the eating up of any metal in presence of components of the atmosphere like oxygen, moisture, sulfur, like that. You must have known rusting of iron. So that is a corrosion chemical reaction and it is a combination reaction. So let us see the chemical reaction or equation for rusting of iron. So remember, iron will not rust if it is only exposed to oxygen. Iron will also not rust if it is only exposed to water. For rusting of iron, there must be oxygen as well as water. In presence of oxygen as well as water, iron rusts. This is most important. So iron metal in presence of oxygen of the air or oxygen gas, and certain number of water molecules. So here number of water molecules in rust is not constant, so that can vary. That is why X number of water molecules. So when iron comes in combination with oxygen and water molecules, it forms Fe2O3 XH2O, and this is the molecular formula for rust. Rust is brown in color or reddish brown in color, and this compound is called ferric oxide. Since water molecules are there, we can call it as hydrated ferric oxide. Call it as a hydrated ferric oxide. So this is the first equation for corrosion of iron, which is called rusting of iron. Rusting of iron is an exothermic reaction, but the amount of heat is slowly released because rusting is a time consuming process. So slowly heat is released. That is why the amount of heat is not sensed. But remember, rusting of iron is an exothermic reaction. Also, one more reason why it is exothermic reaction is because every combination reaction is exothermic in nature. But here amount of heat produced is less because rusting is a slow process. Corrosion of silver. You must have seen silver articles turn black when exposed to air. So silver doesn't corrode due to oxygen or moisture. Silver corrodes due to the presence of sulfur in the atmosphere. So how to show that chemical reaction? Silver, which is metal, solid, when it comes in contact with, say for example, hydrogen sulfide gas. So when silver reacts with hydrogen sulfide gas, a compound is formed which is called silver sulfide, Ag2S, and this is black in color, and this is the corroded form of silver, and along with that hydrogen gas is released. So this is called silver sulfide. Okay, then we'll see what is the reaction for corrosion of copper. So copper corrodes in presence of oxygen and sulfur as well as moisture of the atmosphere. So when copper reacts with oxygen, it forms one of the oxide of copper. So copper oxide, when it reacts with a sulfur trioxide and water molecules, that forms a compound that is the corroded form of copper, which is green, blue in color, green kind of, if you have seen the corroded form of copper, it's a greenish color. And that compound is Cu4, SO4, OH6. This is called 4 copper oxide. So copper metal in presence of oxygen forms copper oxide. When it reacts with sulfur trioxide and water, it forms, don't confuse, this is not copper sulfate, it is Cu4, SO4, OH6, and this is the corroded form of copper. So these all are also combination reactions and exothermic in nature. During corrosion reaction, heat is produced, but since corrosion process is slow, the heat that is produced is not much noticed. Now coming to decomposition reactions, I have already defined decomposition reaction, but remember all decomposition reactions are endothermic in nature. Endothermic in nature's meaning is during decomposition, a single compound absorbs heat energy. As a result, the existing bonds are broken and new bonds are formed between the atoms of elements. As a result, simpler substances are formed. So heat energy is absorbed. So heat energy is not found. Heat energy is absorbed. So these are endothermic in nature. So how to remember the chemical reactions and equations for decomposition reaction? Remember, there are decomposition reactions. So let's begin with the first example of decomposition reaction. It is a decomposition of ferrous sulfate. So it is not just FeSO4, we should have the water of crystallization, that is FeSO4 7. Due to this water of crystallization, ferrous sulfate gets a green color. So ferrous sulfate with 7 water molecules, this is a single compound, and 7H2O is called the water of crystallization, which is responsible for color of this salt. Otherwise FeSO4 is white in color. So right now this is a green in color. Right now means when ferrous sulfate appears in this compound form, it is green in color. And what is name of this compound which is going to decompose by absorbing heat energy? Absorbing heat energy means this has to be heated. As a result, its different compounds are separated off. Few are solid, few are gases, and few are liquid in that way. So this is called ferrous sulfate heptahydrate. So you can make out the meaning of this name, hepta, hexa, hepta, octa. So hepta means 7, hydrate. Hydrate is, it is hydrated with water. So ferrous sulfate heptahydrate, when it is heated. So right now I'm putting a triangle symbol, but don't dare to write the triangle symbol in your board exam. You write on heating. So ferrous sulfate heptahydrate on heating breaks it down to Fe2O3, which is called ferric oxide. So ferrous, ferric. Ferrous is Fe2 plus, a bit unstable. Ferric, Fe3 plus, which is comparatively stable. So ferric oxide is formed. Along with this, this is a solid compound. This is a brown in color. Along with this, sulfur dioxide and sulfur trioxide. So both of them are gaseous form, and with this water is released. And here we don't require much of the balancing. Here Fe2 you see, just put a 2 here, and rest if you just observe 2 into 7, 14 water molecules, and 2 sulfur, so 2 sulfur, rest oxygen, everything is well balanced. So this is the decomposition of ferrous sulfate heptahydrate. This is called a ferric oxide. Next, the decomposition of copper sulfate, but again copper sulfate is white in color, but when it has got some number of water molecules, copper sulfate comes with 5H2O. So this is called copper sulfate pentahydrate. And since it has got the water of crystallization, this has a color and this is blue in color. Copper sulfate. Okay, so this is copper sulfate pentahydrate. So copper sulfate pentahydrate is a single compound. This on heating, again I say don't use triangle symbol because triangle symbol has got 1 meaning in 1 subject. So just neatly write on heating, breaks down into simpler substances like copper oxide. Copper oxide is black in color. Along with this, sulfur trioxide gaseous form is released and water molecules are released. So here if I put 5H2O, this equation is a well balanced equation. So this is the next example of decomposition reaction. Remember, all decomposition reactions are endothermic in nature, means the compound, single compound absorbs heat energy and breaks down into simpler substances. Then the next one is decomposition of silver nitrate. You have to write these equations a good number of times and understand also that what is the compound and what are the things that are formed. So lead nitrate. Lead nitrate is a PbNO3 2. Nitrate is single oxidation state. So here PbNO3. So lead nitrate on heating forms lead oxide, that is PbO, plus nitrogen dioxide and oxygen is released. For balancing, you can write and twice lead oxide, 4 of nitrogen dioxide and this. So twice lead nitrate, 2 lead oxide, 4 nitrogen dioxide, oxygen in gaseous form. So lead nitrate is a colorless substance. You can guess why it is colorless. It is colorless because it doesn't have water of crystallization. That also may be a reason, but this is the nature of the substance. Lead oxide is yellow in color. Nitrogen dioxide is gaseous form and it is brown in color, brown gas. Oxygen is a colorless gas. So these are the 3 decomposition reactions. But other than this, one of the decomposition reaction that I insist you should know is the reaction which is used to explain the manufacture of oxygen gas in industries. That is potassium chlorate, KClO3. Potassium chlorate, this decomposes on heating in presence of a catalyst. Catalyst is a manganese dioxide. What is a catalyst? Catalyst is a substance that when added to this reaction enhances or initiates the reaction but doesn't participate or doesn't get converted itself. So manganese dioxide being a catalyst that catalyzes the reaction, and this decomposes, forms potassium chloride and oxygen. So this also proper balancing. So this is 2 of them, this is 2 of them, and this is 3 of them. So in this reaction, this is the process of manufacturing of oxygen gas. Once I discuss all the types of reaction, I'll take up some of the examples where I will tell you how to balance the chemical reactions. So right now, this is a decomposition reaction. So under decomposition reaction, there are some kind of decomposition reactions which are called photochemical reactions. What are photochemical reactions? Photochemical reactions which are the reactions which are initiated by photo. Photo means a light. So the best examples, silver chloride. This, when it is exposed to sunlight in laboratories, silver chloride, silver bromide are placed in containers which are dark colored bottles. So this when it is exposed to sunlight, it just decomposes to silver and silver metal and chlorine gas. Chlorine gas is yellow in color, and we should go for balancing of this. So here 2, here 2. The similar kind of reaction with silver bromide on exposing to sunlight, breaks down, means it decomposes to silver and bromine gas. Bromine gas is brown in color, chlorine gas is yellow in color. So decomposition reaction, decomposition of ferrous sulfate heptahydrate, decomposition of copper sulfate pentahydrate, lead nitrate, potassium chlorate, silver chloride and silver bromide. The third kind of reaction is called a displacement reaction. Displacement reaction is a reaction or a chemical reaction in which a substance of higher reactivity displaces a substance of lower reactivity from its salt solution. So to know the examples of displacement reaction, it is better that we should know the reactivity series, and then we can write n number of chemical reactions as examples for this. So to understand reactivity series, remember that potassium and sodium stands at the apex, then calcium and magnesium, then aluminium, zinc, iron, followed by lead, and then there is a hydrogen, then copper, mercury, and then gold, silver, platinum. So I remember them in pairs like this as set, like potassium, sodium in one group. That means if you remember like this, then every chemical equation or reaction that is possible for potassium in a particular way happens for sodium also in that particular way. Similarly, calcium, magnesium, same kind of reaction, same output. Similarly, aluminium, zinc, iron will display the same kind of properties. Lead, its own kind of property. Then hydrogen, copper and mercury's chemical reactions are very similar. Similarly, gold, silver, platinum, the lowest of reactive substances, display the same kind of chemical reaction. So it's better that we remember reactivity series in this way. Now let's write some examples for displacement reaction. Very simple. Pick up any substance from the higher reactive space like iron. When it is dipped in copper sulfate solution, so iron nail, when it is dipped in copper sulfate solution, so iron being at higher reactive metal, so this displaces copper from its salt solution or copper from its compound. So we will get ferrous sulfate, which is aqueous form, plus copper metal. So this is what happens. And then we can write a good number of equations like zinc plus most of the reactions are with copper sulfate, aqueous form. So zinc is definitely above in the reactivity series, copper is perfectly below. So this gives a zinc sulfate and copper. Similarly, lead with copper, let's change it, copper chloride. Copper chloride is also in aqueous form. Aqueous and liquid, what's the difference? Liquid means water. Aqueous means a solution of a substance in water is aqueous. So copper chloride gives lead chloride. So PbCl2 and copper. So copper is the metal form. Now coming to double displacement reaction. Double displacement reaction is a reaction in which two compounds when they react with each other or combined, the ions exchange the locations and form completely new compounds with different properties is formed. Most of the displacement reactions are precipitation reactions. And what is a precipitation reaction? A chemical reaction in which an insoluble substance is formed and that insoluble substance stays like a precipitate, like that is not a state of matter. It's like some solid substances staying suspended in liquid, that is called precipitate. So most of the displacement reactions are a precipitation reaction. Double displacement reaction, few of those, whenever I use a word popular equations, I mean that those are the equations which often appears in the examination. So double displacement reaction, three of them we better remember. One is barium chloride, BaCl2, when it reacts with sodium sulfate. both of them in aqueous. Reaction will be possible when solid reacts or combines with a liquid state, or both of them are in liquid state, so that they combine and some new substance is formed. So barium chloride, aqueous form. Sodium sulfate, also aqueous form. So here double displacement, that means barium combines with sulfate ion and sodium combines with chloride ion. So we get a barium sulfate, BaSO4, and sodium chloride, NaCl. And this needs balancing. Okay, so 2 NaCl, and this is well balanced. Remember, barium sulfate is the white precipitate. So barium chloride plus sodium sulfate gives barium sulfate and sodium chloride. Barium sulfate is the white precipitate that forms here. Next one, lead nitrate. Lead nitrate, PbNO3 2. When it reacts with potassium iodide, lead iodide is formed. So PbI2 is formed, and potassium nitrate is formed, KNO3. So this needs a balancing. So here 2. And lead iodide is the yellow precipitate. So this reaction is not directly written in the NCERT textbook, but this is written in the blue case in the left side page where you come across double displacement reactions. There the NCERT expects that this activity to be done in the laboratory, and when you see the yellow precipitate, that is a feast for eyes. Very beautiful yellow precipitate of lead iodide can be seen. So lead nitrate plus potassium iodide gives lead iodide and potassium nitrate. So KNO3, so 2K, so we have to put here 2 and 2 iodine. So now it is well balanced. Next, copper chloride, CuCl2 plus hydrogen sulfide. Hydrogen sulfide is a gas, but copper chloride is the aqueous form. So this forms copper sulfide and hydrochloric acid, HCl, and this needs a balancing. Okay, so copper sulfide is the black precipitate. Though it is said it is black in color, but the precipitate is feast for eyes again. So all these three, when they are performed in the laboratory, they are a real feast for eye. White precipitate is really milky white. Yellow is the what is it called? I just forgot that the special kind of yellow. And copper sulfate is a black precipitate, a very beautiful black precipitate. So this is about a double displacement reaction. Now coming to oxidation reaction. What is the meaning of oxidation reaction? Oxidation reaction is addition of oxygen or removal of hydrogen or loss of electron. So oxidation reaction would mean addition of oxygen or removal of hydrogen or loss of electrons. So let me give you some examples of oxidation reaction. The best one is there in the textbook, where copper powdered form is taken in a watch glass, and that is heated, not watch glass, china dish, and that is heated in air. As a result, it forms copper oxide. So copper plus oxygen, it is heated, so on heating forms copper oxide. So gain of oxygen is called oxidation reaction. So similarly, sodium metal, when it is exposed to air, it burns with explosion for sure. So, but that is also an oxidation reaction. So here we need not say on heating. At room temperature, that temperature is enough for sodium because it's highly reactive metal. It forms Na2O. So this is oxidation reaction, solid form. So this needs some balancing. So 4 of it, so 2 of it. So this is oxidation reaction. Now reduction reaction, what is the meaning of reduction reaction? Reduction is the addition of hydrogen or removal of oxygen or gain in electrons is called reduction reaction. So the example of reduction reaction can be a continuation of oxidation reaction like copper oxide. So copper oxide, through which if hydrogen gas is passed, this forms copper and water. This is a reduction reaction. Also remember, in metallurgical operations, carbon or coke is used as a reducing agent. What is the meaning of reducing agent? What is the meaning of reduction? In fact, reduction is a process of metal extraction like naturally occurring say zinc oxide. So from here zinc has to be extracted. So carbon is the reducing agent. So when zinc oxide is treated with coke or carbon, we will get metal zinc and carbon dioxide. So this is a process of reduction or reducing. So metallurgical operations, carbon is used as a reducing agent for metal extraction. So here metal is extracted and reduction has occurred. So now a combination of oxidation and reduction is called redox reaction. So let me give you some examples of redox reaction. Let us take an example. So copper, when it is heated in presence of air, it forms copper oxide. So here copper oxide is formed. So through this copper oxide, if a stream of hydrogen gas is passed, then this reaction is reversed, due to which copper metal is formed and water is produced. So in this is the redox reaction. Here copper oxide is reduced to copper and hydrogen is oxidized to water. Let's take one more example of redox reaction. Here manganese dioxide, when it is treated with hydrochloric acid dilute, this forms manganese chloride, water and chlorine gas. In this case, manganese dioxide is reduced to manganese chloride and hydrochloric acid is oxidized to chlorine gas. This equation need balancing. MnO2 plus 4HCl gives MnCl2, water and chlorine gas. Manganese dioxide is reduced to manganese chloride and hydrochloric acid is oxidized to chlorine. Now that we have learned the different types of chemical equations and reactions, let's see how to balance them. For that, I have written some examples here. So the procedure for balancing a chemical equation. So this is an example of it. So the procedure is have the columns for the atoms which are there in the equation, then the reactant column and the product column. So what atoms are there in this equation? It is iron, hydrogen, oxygen. See here also iron, oxygen, hydrogen. So while listing down, see that first you list down the metals and non-metals in the reaction, then hydrogen, at last oxygen. Because in the process of balancing a chemical equation, first oxygen atoms have to be balanced, followed by hydrogen, and then the metals and non-metals whichever appear in the reaction will automatically be balanced. So we need not specially think about them. So now in the reactant side, means left side, how many of these atoms are there? We have to count and write. So how many iron atoms are there, Fe atoms are there in the reactant side? You see there is only one. How many hydrogen are there? 2 of them. How many oxygen atoms are there? 1. In the product side, how many iron atoms are there? So there are 3 of them. How many hydrogen are there? There are 2 of them. How many oxygen are there? There are 4 of them. So always while balancing a chemical reaction or equation, balance the oxygen atoms, then the hydrogen atoms, and the remaining metals and non-metals will automatically be balanced, remember. So now in product side is 4, reactant side is 1. So here in reactant side we multiply 4. So oxygen is balanced. So since we have written 4 in reactant side for oxygen, search for oxygen on reactant side and put 4 there. When we do so, oxygen is 4 in reactant and product. But here, because we have placed 4 here, hydrogen is 4 into 2, 8 in the reactant side. So here 2 is there and we have multiplied 4. So hydrogen is 8 on reactant side. So on product side also it should be 8. So here also we multiply 4 so that oxygen is balanced and hydrogen is also balanced. But since we have written 4 here, in the product side we have to search for hydrogen and put 4 there. So hydrogen is here, we are putting 4 here. So now you see hydrogen is balanced, oxygen is also balanced. Then what about iron? Iron and put here 3. This is a well balanced chemical equation. Now I have picked up some questions from the in-text blue questions. So page number 6, question number 2, there are some blue questions. The question is, write the balanced equation for the following. So the question is, hydrogen plus chlorine is hydrogen chloride. How does the equation look like? Hydrogen is a diatomic, so we should write H2. Chlorine is also a diatomic, so Cl2, which gives a hydrogen chloride. Hydrogen chloride looks like HCl. How do you balance? So here you need not write that atoms, reactants, product. By seeing itself you can make out 2 hydrogen is there in the reactant side, 2 chloride is there in the reactant side, and in the product side there is single of hydrogen, single of chloride. So once you place 2 here, this is a well balanced chemical equation. Next to that, the blue question, barium chloride. So I am writing it barium chloride, BaCl2. How to understand this compound? Barium has oxidation of 2 plus. Chloride means 1 minus or minus 1. So we go for this crisscross method. As a result we get barium chloride, BaCl2. Then aluminium sulfate. So right now I am writing aluminium as Al, and we know that sulfate is SO4. Aluminium oxidation state is a 3 plus. Sulfate is a 2 minus. Go for crisscross. And how does the compound of aluminium sulfate look like? It is Al2, SO4 3. So put SO4 in a bracket and put 3 here. This results in, when these two react, this results in barium sulfate. Barium sulfate is a BaSO4 because 2 plus 2 plus. So this one plus aluminium chloride. So I am writing aluminium as Al, chloride as Cl. Aluminium oxidation state is a 3 plus. Chloride is 1 minus or minus 1. Go for crisscross. So Al1, Cl3. So AlCl3. So this is how the equation looks like. Now let's balance this equation. So our equation is, I hope this is visible in the camera. So our equation is BaCl2 plus aluminium sulfate gives a barium sulfate and aluminium chloride. So let's list out all the atoms that is there in this chemical equation. So atoms in the equation are barium. So when you write the list of atoms, first list down all the metals and non-metals and then write hydrogen. At last write oxygen, because we will start balancing the oxygen, then hydrogen, and the metals and non-metals will automatically be balanced. So barium, then there is aluminium, so these are metals, then there is sulfur, non-metal, and in left side we have barium, chlorine, okay, so chloride, non-metal. So we have barium, chloride, aluminium, sulfate. So there is no hydrogen but there is oxygen. So oxygen has to be written at last. Now let's see how many atoms of these are there in the left side, means a reactant, and in the right side, that is the product side. So barium, one of them, and aluminium in left side is 2, sulfur in left side is 3, chloride in left side is 2, oxygen in left side is See, chloride 2, barium 1, aluminium 2, sulfur 3. Oxygen is 4 3s 12. So oxygen is 12. On the product side, barium is 1, aluminium is 1, sulfur 1, chloride 3, oxygen 4. So on the product side, barium 1, sulfur 1, oxygen 4, aluminium 1, chloride 3. Now let's balance this equation. So I said balancing should be, okay, I should have this equation. Okay, balancing should be done from oxygen. So here 12 in the reactant side. So in the product side, we multiply 3. So oxygen is balanced. Since in the reactant side I have multiplied 3, in the reactant side where I will see oxygen, there that compound in front I should write 3. On doing so, oxygen in right side is 3 4s 12. In reactant side, product side is 3 4s 12. In reactant side, 4 3s 12. But because we have kept 3 here, barium in the reactant side became 3, sulfur in the reactant side also became 3. So sulfur is also multiplied to 3 and barium is also multiplied to 3. So with this, oxygen is balanced, sulfur is automatically balanced, but barium is not balanced. Product side 3, reactant side 1. So reactant side, let's multiply 3. So reactant side where we see barium, there I am putting 3. So now barium is also well balanced. But because we have kept 3 here, chloride becomes 3 2s 6 in the reactant side. So chloride becomes 6. 6 means 2 into 3, 6. To balance the chloride, right side we should multiply 2, and wherever we see chlorine, there we have to put 2. So right side Cl3 is there, we have to put 2. Now chlorine right side 2 into 3, 6. Left side 2 into 3, 6. So chlorine is also balanced. What is left is aluminium. So aluminium in left side is a 2. But when we kept 2 for chlorine, aluminium became automatically 2 in the product side. So here automatically 2 came. Now barium balanced, aluminium balanced, sulfur, chloride, oxygen, all of them is balanced. And how is the well balanced equation of this reaction look like? 3 BaCl2 plus Al2SO4 3 BaSO4 plus twice aluminium chloride. So this is a well balanced equation. Let's take few more examples to understand how to balance a chemical equation. Sodium, this I am writing M plus water gives sodium hydroxide and hydrogen gas. So sodium is Na, water, H2O, NaOH, sodium hydroxide, because Na is +1 oxidation state, hydroxyl ion, OH minus oxidation state, and hydrogen gas. How to balance it? Let's write the number of atoms in the reactants and products: sodium, hydrogen, oxygen. Always keep oxygen the last, because first we'll balance oxygen, then we will balance hydrogen, and the remaining metals and non-metals will automatically be balanced. How many sodium atoms are there in the reactants? 1, hydrogen 2, oxygen 1. In the product side, sodium is 1, hydrogen is 1, 2, 3, and oxygen is 1. So Na is single, then there is a single OH. If we put here 2, we will have double OH. That means something like here 4 hydrogen is there. So 2 of them here, and 2 oxygen, 2 of them here. Then 2 hydrogen. So out of this 4 hydrogen, 2 are here, remaining 2 are here. Because sodium is 2 here, so I am putting here 2. This is actually a well balanced equation. See, now here sodium 2, right side also 2. Hydrogen in the left side is 2 into 2, 4. Okay. In the product side, 2 into, okay, 2 hydrogen, and here 2 hydrogen. So totally here also 4. So this 3 we can avoid, and we can directly write 4. So in the reactant side, 4 of them. In the product side, 1, 2, 3, 4. So this is balanced. Oxygen in the reactant side 2, in the product side also 2. So here 2, 4, 2. This is the well balanced equation. Now coming to the textbook exercise questions. The first question, which of the following statements about the reaction below are incorrect? I have written the question here in this paper. The equation is 2 lead oxide plus carbon gives 2 lead and carbon dioxide. So 4 options are given. We have to tell which of these as per this options is correct. The first one, lead is getting reduced. Actually in the reactant side there is no lead to get reduced. So lead is getting reduced, that statement is not correct because reactants lead is not there. Second, carbon dioxide is getting oxidized. Sounds correct. Why? Because that is also incorrect because carbon dioxide is getting oxidized. In the reactant side there is no carbon dioxide also. So the first 2 statements are clearly incorrect and we have to choose the incorrect statement. The third one, carbon is getting oxidized, very much correct. In the reactant side we have carbon. So carbon became carbon dioxide. So carbon was oxidized. And the fourth option, lead oxide is getting reduced, and that is also true. The oxide form, from the oxide form, carbon, which is a reductant, reduced it from lead oxide to pure metal lead. So carbon is getting oxidized is true, lead oxide is getting reduced is also correct. The first 2 statements are wrong, A and B. So the first option is the correct answer. Then the second question, we are given one equation. We have to identify the above reaction is an example of what. So here Fe2O3 ferric oxide plus aluminium gives aluminium oxide and iron. So what is this equation? This is clearly a single displacement equation, or you can call it as a displacement reaction. So this is a displacement reaction. The third question, what happens when dilute hydrochloric acid is added to iron fillings? So it is like a reaction of metal with acid, dilute form. Reaction of metal with acid always releases hydrogen gas. So we will get here FeCl, FeCl2 or FeCl3 and hydrogen gas. So hydrogen gas and iron chloride is formed, very much correct, and other options I need not see because this is the answer. Coming to fourth question. Fourth question is, what is a balanced chemical equation and why should chemical equations be balanced? So I have written the answer to this. A chemical equation having an equal number of atoms of different elements in the reactants and products is called a balanced chemical equation. And why do we balance a chemical equation? So that the law of conservation of mass is satisfied. So as an example, I have taken metal reaction with a dilute sulfuric acid. Zinc plus H2SO4 gives ZnSO4 and hydrogen gas. Chemical equations are balanced to satisfy the law of conservation of mass. And what is law of conservation of mass? It states that matter is neither created nor destroyed in a chemical reaction. That means total number of atoms in the reactant side is always the same as the total number of reactants on the product side. Now question number 5. The question is, translate the following statements into chemical equations and then balance them. So the first one, hydrogen gas combines with nitrogen to form ammonia. Ammonia is a gas, NH4. So here hydrogen gas, hydrogen is a diatomic, so we will write H2, combines with nitrogen gas, nitrogen is also diatomic, so N2 gives ammonia. Ammonia is NH3, NH4 is ammonium ion, but NH3 is ammonia gas. So H2 plus N2 gives NH3. The balanced form is a 3H2 plus N2 is a 2NH3. The second one, hydrogen sulfide means H2S gas burns in air. So combustion of hydrogen sulfide gas gives water and sulfur dioxide. So H2S plus O2 gives H2O plus SO2. On balancing, we will get 2, 3, 2, 3. Okay, so in case this balancing is not understood, I am doing the balancing of this equation here. So H2S, okay. So what are the atoms we have? We have sulfur, we have hydrogen, we have oxygen. On the reactant side, on the product side. Reactant side, there is before balancing, there is 1 sulfur, There are 2 hydrogen and 2 oxygen. Product side, there is a single sulfur, 2 hydrogen and 2 plus 1, 3 oxygen. So how to balance this? Hydrogen is already balanced, sulfur is balanced, but oxygen is not balanced. So that is the reason we always should start from balancing of oxygen. How it appears as if I should multiply in the reactant side 3. When I do so, this becomes 6. So right side also, the product side also, there should be 6 oxygen. Since I multiplied 3 here, so oxygen I kept 3 here. So 3 O2. And though I have multiplied 2, but there is no single oxygen there where I can just write 2. That's why this I have to distribute over them. So now left side, reactant side 6 oxygen, right side 2 SO2 and 2 H2O. When we do so, there will be 2 oxygen plus 4, 2 plus 4, 6. Since we kept 2 here, hydrogen became 4. So left side where you see H2, there we write 2. So hydrogen is balanced, but in this process sulfur became 2 in the reactant. So put this, already 2 is there, so sulfur is already balanced. So hydrogen is okay. So the balanced form, oxygen 6, hydrogen 4, sulfur is 2. So that sulfate, aluminium chloride, barium sulfate. This balancing I have shown just before this textbook exercise question. There you can see, and you can see how this compounds are written and how the balancing is done. Last one, potassium metal reacts with water, gives potassium hydroxide and hydrogen gas. A similar kind of reaction done with sodium. Sodium also burns with when it reacts with water, and it ultimately burns with explosion. So the same thing happens with potassium. This kind of reaction also is shown just before I started textbook exercise question. So K plus H2O gives KOH and H2. So 2 of them here, single hydrogen gas. Then sixth question, balance the following chemical equation. So now I will really take up these equations and balance them. The first one, nitric acid plus calcium hydroxide. Acid plus base gives salt and water. So let's balance. What are the atoms involved? Atoms involved is, first we'll write the metals and non-metals, then hydrogen, then oxygen. So we have calcium. So reactants and products. So calcium, then we have nitrogen, then hydrogen, ultimately oxygen. The reactant side, single calcium, single nitrogen, hydrogen 2 here plus 1, 3, oxygen 3 here, 4, 5, oxygen 5. Product side, single calcium, nitrogen 2, 2 of them, hydrogen 2 of them, and oxygen is 3, 2 is a 6, 7 of them. How to balance? Okay, so here we can't take LCM of these two and do, but I guess we can do this. HNO3. So I place 2 hydrogen here so that hydrogen is balanced. So 2 here, so 4 hydrogen is balanced. See, oxygen is 3, 2 is 6, 7, 8. And in the product side 6, 7, 8. So this is also balanced. On placing 2 here, nitrogen became 2. So here 2, and nitrogen is already 2. So nitrogen is also balanced, and calcium is already balanced. So the balanced equation is 2 nitric acid plus calcium hydroxide gives calcium nitrate and 2 water molecules. The second one, sodium hydroxide plus sulfuric acid gives sodium sulfate and water. When we cannot balance from oxygen first, then we can balance the hydrogen and then we can go for oxygen. So which are the atoms involved? Sodium, sulfur, hydrogen, oxygen. In the reactant side, 1 sodium, 1 sulfur, hydrogen 1 to 3, oxygen 4, 5. And in product side, 2 sodium, 1 sulfur, 2 hydrogen, and 4, 5 oxygen. So oxygen is well balanced. So we have to balance hydrogen 3 and 2. So if I place here 2, we have here 2 plus 2, 4. So hydrogen is 4, and on placing 2 here, hydrogen is 2 into 2, 4. So here hydrogen is balanced, oxygen is already balanced. But when we placed 2 here, sodium became 2, and now sodium is also balanced. Sulfur is already balanced. So the balanced equation is 2 sodium hydroxide plus sulfuric acid gives sodium sulfate and 2 water molecules. The next one, 6th question, 3rd bit, sodium chloride plus silver nitrate gives silver chloride and sodium nitrate. So what atoms are involved? So the C bit is this. So number of atoms, reactants, products, I have written all of them. Sodium, silver, nitrogen, oxygen, but there is a chloride ion also. Now as I listed how many atoms are there in the reactants and products, all of them were matching, including, there is no space for this, so I could not write chloride, but here reactant side 1 chloride and product side also 1 chloride. So this is a well balanced equation. Next one, barium chloride with sulfuric acid gives barium sulfate and hydrochloric acid. Let's balance. In the what atoms we have? We have barium, we have sulfur, chloride, hydrogen, and oxygen. So reactant side we have barium, we have sulfur single, chloride 2 of them, hydrogen 2 of them, oxygen 4 of them. Product side we have barium, single sulfur, single chloride, hydrogen single, oxygen 4 of them. So it is not a well balanced equation. So multiply 2 here, multiply 2 here. As a result, just place 2 here. Now this is a well balanced equation. That's it. Now coming to question number 7. Question number 7 is write the balanced chemical equations for the following. So we have to write the equation and we have to balance them. The first one, calcium hydroxide. How do you write calcium hydroxide? Ca2 plus. Hydroxyl is OH single minus. So if this is 2, this is 1. Crisscross, so you get CaOH2 plus carbon dioxide CO2, calcium carbonate CaCO3, calcium carbonate plus water. Let us see about the balancing part. Is it a balanced equation? Single calcium, 2 oxygen, 2 plus 2, 4 oxygen. So 3, 1 matching. 2 hydrogen, here it's a well balanced equation. Then zinc plus silver nitrate. How do we write silver nitrate? AgNO3 gives a zinc nitrate ZnNO3, that's all, no bracket. ZnNO3, but Zn is 2 plus nitrate means 1 minus, so crisscross, so it gets ZnNO3 2 plus silver. Is it a well balanced equation? Let's see. Zinc single, silver single, nitrogen 2 of them, oxygen 6 of them. So nitrogen 2, so here 2 is there, so just place 2 here. So 2 nitrogen, 6 oxygen, 2 nitrogen, 6 oxygen. But since we placed 2 here, silver became 2 atoms, so here 2. This is the well balanced equation. Now question number 8. The question is write the balanced chemical equations for the following and identify the type of reaction. Excellent. So potassium bromide. How do we write potassium bromide? Potassium is a K, single oxidation state. Bromide is also single oxidation state. So Br, so KBr plus barium iodide. So barium is 2 plus, iodide is single oxidation state. So this is barium Ba2. See, So this is something like a BA and I. This is 2 plus and this is 1 minus. So go for crisscross to identify how the compound look like. So then this on reaction. So it is kind of double displacement. So potassium iodide, this forms a Ki, and barium bromide. So Ba, Br2, because bromide is also single oxidation state, but barium is a double oxidation state. Now let's balance this. Single barium, okay, single potassium, but double iodine. So if you put here 2, so this becomes a 2. As a result, potassium balanced, bromine balanced, barium. So it's a well balanced equation. So this is identify the type of equation. So this is a double displacement reaction, and every double displacement reaction is a precipitation reaction. So you can call this reaction as precipitation reaction. Okay, exceptions always there. So this is a precipitation reaction and also a double displacement reaction. Next one, zinc carbonate. So zinc Zn2 plus actually, carbonate CO3 single minus. Carbonate 2 minus. So zinc carbonate ZnCO3, like calcium carbonate CaCO3, zinc carbonate ZnCO3. On decomposition gives a zinc oxide and carbon dioxide. It is a well balanced equation. You see number of atoms on either sides is same. So what is the kind of reaction? It is the decomposition reaction. The C bit of 8th question, hydrogen diatomic, chlorine diatomic, combines and forms the HCl. What kind of reaction? You can clearly see and understand that it is a combination reaction. Combination reaction. How to balance? Each of them are 2 of each, so put 2 here, that is balanced. Magnesium Mg reacts with HCl. So it is like metals react with dilute acid, gives metal chloride and hydrogen gas. So MgCl, but how many atoms in combination? Mg comes in 2 plus, chloride, so 1 minus, go for crisscross. So Mg1 Cl2 and hydrogen gas. About balancing, Cl2 is there, let's put 2 here. Due to this, hydrogen becomes 2. So it is already 2. So this is a well balanced equation, and this is a displacement reaction. Like magnesium displaces hydrogen from the compound HCl. So it is a displacement reaction. Displacement reaction. Magnesium has displaced hydrogen from the acid, and as a result forms magnesium chloride and hydrogen gas. Next, 9th question. The question is, what does one mean by exothermic reaction and endothermic reaction? Give one example of each. So I could have written the answer ahead of time, but I did not do that because I want to recapitulate the point that what are exothermic reactions? Exothermic reactions are all those chemical reactions which release heat energy after the reaction is over. Endothermic reactions are all those reactions which absorb heat energy when the chemical reaction is going to occur. And every exothermic reactions are combination reaction. Oh, you can tell like this. Every combination reaction is exothermic in nature. Every combination reaction is exothermic in nature, and every decomposition reaction is endothermic in nature. Every decomposition reaction is endothermic in nature. You just remember like this. So you can remember definition. Exothermic reactions produce heat energy at the end of the reaction, and endothermic reactions absorb heat energy. Means output is a chilling, some low temperature is attained. Also remember that every combination reaction is exothermic in nature and every decomposition reaction is endothermic in nature. They wanted us to give example. Well done. Give an example of combination reaction and that becomes exothermic. Combination reaction is quicklime with water gives calcium hydroxide, And whenever you write slaked lime is formed, so quick lime gives slaked lime. Whenever you write this is a combination reaction, but complete the reaction. So this calcium hydroxide on combination with carbon dioxide of the atmosphere gives calcium carbonate and water. So this is example of combination reaction which is exothermic in nature. Example of endothermic reaction, give an example of decomposition reaction. Very simple one is silver chloride on exposed to sunlight gives silver, and chlorine gas. Chlorine gas is yellow in color. So a balancing. So this is endothermic in nature and this is exothermic in nature. Question number 10. Why is respiration considered as an exothermic reaction? Explain. So why respiration is considered exothermic? Because it results in emission of heat energy. So heat energy is produced. Respiration is opposite to photosynthesis reaction. So if you remember photosynthesis reaction, just write the product as a reactant and reactant as product and becomes respiration. Respiration is the process that undergoes in our body that generates heat energy, and that heat is used for the body function. So in respiration reaction, glucose C6H12O6 combines with oxygen. That means the food that we eat gets converted to glucose, and when we breathe in oxygen, so it combines with oxygen to produce carbon dioxide and water and heat. So CO2, H2O, and heat energy is produced. This heat energy is needed for the body temperature maintenance, our functioning, the metabolic activities. For that, this heat energy is needed. So how to balance? Very simple. Oxygen, carbon dioxide, water, all of them 6. So glucose plus oxygen gives carbon dioxide, water, heat. This is respiration. It's a reverse, means carbon dioxide and water in the atmosphere in presence of sunlight and chlorophyll gets converted to glucose. In this way, food is prepared by plants, and in this process heat is produced. Every combination reaction is exothermic in nature. So here combination occurs, though simple substances are formed, but this reaction is exothermic in nature because heat is released. Question number 11. Why are decomposition reactions called opposite of combination reaction? Write the equations of these equations. Decomposition reaction is a reaction in which one single compound under certain condition, means on heating, on exposed to sunlight, or when electric current is made to pass through, breaks down to simpler substances. Whereas combination reaction is a reaction where two or more simpler substances combine under certain condition to form a single substance and heat energy is produced. So decomposition reactions are endothermic in nature, means they absorb heat energy. Combination reactions are exothermic in nature, means they liberate or give heat energy. So in combination reaction, two or more substances combine to form a single substance, whereas in decomposition reaction, a single substance splits up to form two or more simpler substances. Writing equations for this, let's write for decomposition. We know water, when electric current is made to pass through water, when electric current is made to pass through water, it decomposes to hydrogen and oxygen gas. This process is called hydrolysis of water. So this is a decomposition reaction. Its reverse is combination reaction, means hydrogen gas on reacting with oxygen gas, hydrogen and oxygen combine to form water. So the first one is a decomposition reaction and the second one is a combination reaction. So in decomposition reaction, water absorbs energy and breaks down to simpler forms, and in combination reaction, simpler forms combine to form a single substance, and in the process energy is released. Question number 12. Write one equation each for decomposition reaction where energy is supplied in form of heat, light, electricity. Very simple. Take decomposition of calcium carbonate. Calcium carbonate, when it is a heated solid form, okay, so when it is heated, breaks it down or decomposes to calcium oxide, that is in flakes, and carbon dioxide gas is released, CO2. In presence of light, write the usual one, silver chloride or silver bromide decomposition in presence of sunlight. Photochemical reaction. This is Ag plus Cl2. So chlorine is a gas, silver is solid. So here 2, here 2. About electricity, water, H2O, liquid form, through which when electric current is made to pass, it decomposes to hydrogen gas and oxygen gas About balancing, 2H2O gives hydrogen gas and oxygen gas at the respective electrodes. Then 13th question, what is the difference between displacement and double displacement reactions? Write equation of each of this. I have written a very simple definition. In displacement reaction, in a displacement reaction, a more reactive element displaces a less reactive element from its salt solution or compound. This I have discussed in the beginning part where the concept is discussed. There I have written the reactivity series, and you can easily identify that which element has the capability of replacing which one based on the ranking order. About displacement reaction, very easy. Remember that reaction of metals with dilute acids. So zinc with dilute HCl gives ZnCl2 and hydrogen gas. So zinc displaced hydrogen from this acid and became zinc chloride, and hydrogen gas is released. In double displacement reaction, two compounds combine by an exchange of ions to form a new compound. Very simple. The best example is barium sulfate formation. So barium chloride plus sodium sulfate, Na2SO4, both of them in aqueous form, forms barium sulfate, white precipitate, BaSO4, and sodium chloride. This we can balance. I think balancing is done. So this is the white precipitate, and this is the double displacement reaction. Okay, so you can have still more good example. Lead nitrate plus potassium iodide gives lead iodide, and potassium nitrate, KNO3. Their lead iodide is a yellow precipitate. That is also a double displacement reaction. Now 14th question, in the refining of silver, the recovery of silver from silver nitrate solution involved displacement by copper metal. Write the reaction involved in this. So silver nitrate is AgNO3 plus copper. Okay, so remember copper is above gold, silver, platinum in the reactivity series. So copper can very easily displace silver from this compound. So this forms a copper nitrate, CuNO3. But here silver is a +1 oxidation state, nitrate is -1, so AgNO3. But copper is 2+ oxidation state. So this is 2+. This is nitrate. Nitrate means 1 oxidation state. So go for crisscross, Cu1, but NO3 2. So put a bracket and write this, and silver Ag. So NO3 became 2. But here NO3 is single, so put here 2. As a result, silver is 2, so put here 2. So this is the reaction involved. Then 15th question. 15th question is, what is meant by precipitation reaction? Precipitation reaction is a reaction in which a precipitate, an insoluble compound, is formed when kind of double displacement reaction. A chemical reaction in which an insoluble solid, that is the precipitate, is formed that suddenly separates from the solution, and that is called precipitation reaction. Give an example if they say. We can give very good number of examples for this. Example of precipitation reaction. Just now I wrote barium chloride, sodium sulfate gives barium sulfate and sodium chloride. Now I am writing the other one, lead nitrate, PbNO3, lead nitrate plus potassium iodide gives a lead iodide, PbI2, and KNO3 KNO3. So it needs balancing. So this, so here too. So now this is balanced, and lead iodide is yellow precipitate. Yellow precipitate. You can also write barium sulfate formation, which is a white precipitate. Now 16th question. Explain the following terms. Explain the following terms in terms of gain or loss of oxygen with two examples. So oxidation reaction. Oxidation is addition of oxygen, removal of hydrogen, or loss of electron. That is how we define oxidation. Simple example, magnesium, burning of magnesium ribbon in air. So first, magnesium ribbon has to be scraped with sandpaper to remove the dirt and oxide layer that is naturally formed when it is in air. So magnesium ribbon, when it is heated to a certain temperature in presence of oxygen, it forms magnesium oxide, MgO. And here magnesium is oxidized. So here magnesium is oxidized. So next example of oxidation. Oxidation, we can take copper, the activity that is given in the textbook. Copper, when it is heated in presence of air, becomes copper oxide. Copper is oxidized. What is reduction reaction? Reduction reaction is addition of hydrogen, loss of or removal of oxygen, and gain of electrons. Example of oxidation reaction, copper oxide. When it is treated with, a stream of hydrogen gas is passed through copper oxide. This gives copper and water. So here this is a redox reaction in a way. Copper is reduced, hydrogen is oxidized. We can give one more example, extraction of metal from their oxides. So in extraction of metals, carbon is the reducing agent. So zinc oxide plus carbon gives zinc metal. So zinc is reduced. So carbon is oxidized, carbon oxides, carbon monoxide. So maybe if more number of oxygen is there, this becomes, after that, carbon monoxide can become carbon dioxide also. So this is the reduction reaction. 17th question. Shiny brown colored element X on heating in air becomes black in color. You can guess it that this is copper oxidation. Name the element X and the black color compound formed. Shiny brown colored element is copper. This is that X. Shiny brown colored element X. X is copper. On heating in presence of air. So from air, oxygen it can take. So on heating forms copper oxide, and this is black in color. So name the element X. X is copper. The black colored substance is copper oxide.